Okay, so this is a week 5 topic number 1, 4 more charges, which is an optional problem. But the problem says draw the Lewis structures on this. So the Lewis structure, you have to put the number of valence shell electrons, and then you need to make connections, and then trying to stabilize those original structures by minimizing the 4 more charges, by moving the lone pair electrons. And then this is the one that you would ended up having it. And I'm here more focusing on trying to calculate the 4 more charges, and that's my focus on this problem here. Okay, so the first one is NO plus, and so if you look at nitrogen here, nitrogen is 5 in the valence shell electron minus lone pair electron, there are 2 of them, and half of 3 bonds, 6 electrons. So therefore, this is 0, okay, 5 minus 5. So this is 4 more charges, 0. And as you already know, this is a plus 1 charges, so you can speculate that, and this one must be plus 1, because 4 more charges of molecule, or essentially it is just a simple charge. It's not 4 more charges, but I would just say 4 more charges molecule is a summation of 4 more charges of all the atoms. So if you have all the atoms, first one to the last one, if you have 4 more charges of all the atoms, if they are having them, you don't have to calculate the last one because it is just what is left over. But to confirm this, once again, 4 more charges. Oxygen, right here, oxygen means 6, minus how many lone pairs? I see 2 lone pairs, and half of how many bond electron? 3 bonds, 6 electrons. So that's 6 minus 5, that's a plus 1. Just to confirm, this is plus 1. Okay. The last one is NO2, and this one, the 4 more charges is 0. This one, 4 more charges minus 1, and that has been quite well many times discussed. Once again, this is an oxygen, so 6 minus 4 plus half of double bond, which is 4 electron in the bonding electrons. So that's minus 0. Okay, so the other one, like I said, 6 is an oxygen minus 6 lone pair electrons and half of 2 electron in the bonds. So that makes 6 minus 7. This is minus 1. And I still prefer not to calculate the 4 more charges following the formula, but just following the negative 1 charges there. And if you have no charges, 4 more charges of n plus the 4 more charges minus 1 must be minus 1. So therefore, this gotta be 0. Okay? So that's one way to find out. But to confirm this, you can just do that. 4 more charges. Nitrogen is 5. Lone pairs, there are 2 of them. How many bonds do you see around the nitrogen? 3, so 6 electrons. So that makes it 5 minus 5, which is a 0. Okay, there you go. So so there are 4 more charges. So we have a 4 more charges of 0, minus 1, and 0. So this minus charge is essentially more focused on one of the oxygens in here, which is better because oxygen is electronegative. So let's look at the SB. SB, which is an antimony, and then this is right here, which is what column is it? This is a 5. Okay. So you can think about SB is having 5 valence shell electrons, but you have forming a bond with a chlorine. and that's forming a bond. And this is a 2 electron, one from chlorine, and one electron from antimony. But they need 6 of them, but you are 1 short. So what you need is an extra electron. That electron is actually coming from here. Okay, so that's how you can figure it out. Why there's a 4 more charges of -1 is needed to satisfy all the bonds with the surrounding 6 chlorines. Okay, as far as the 4 more charge is concerned, once again, this is a chlorine. Halogen is 7. 7 minus lone pair, there are 6 of them, and half of how many bonds? 1 bonds, 2 bond electrons. So that's why half times 2 bonds electron. So that means 7 minus 7. That's a 0 electron. There are 0 4 more charges. So this all of them here has a 0 4 more charges. 0, 0, 0, 0, 0. And then like I mentioned before, because this one has a -1 4 more charges, this column has a -1 4 more charges, and that's what you can find out. And just to confirm this, once again, the Sb means you have a 5 valence electron, as you find out from here, right? So that's antimony, that's number 5. So 4 more charges is, you start from 5 minus how many lone pairs? None. And then half of how many bonds you have? 6 bond, which is a 12 electrons in the bond. Okay, so 5 minus 6 is -1. So you just confirm that the 4 more charges of antimony is in the 0, is a -1 in here. The last one is IO3 minus. So once again, this is a negative charge. By now, I think this is the last step, so you should be quick enough to not to spend too much time on it. The 4 more charges is 0, 0, and that's a -1. Okay, and that has been discussed exactly in the same 2 problems here, right? And that's a 0, and this is a -1. That's the same problem. So by quickly doing so, you have a -1 charges. That means I don't really need to calculate this using calculator. I can just say that that's a 4 more charges of 0. Once again, the summation of all the 4 more charges must be equal to -1, and you have a -1 already in the oxygen with a single bond with 3 lone pairs. But okay. But I can do that following the 4 more charges of iodine. Okay, iodine, where is it? Here, which is a column 7, right? That's a halogen column. So iodine is 7 valence electrons and minus how many lone pairs do you see right here? 2. Okay. And how many bonds do you see? 1, 2, 3, 4, 5. You see the 10 electron in bonds. So that makes it 7 minus 7, which is a 0. So that's the 0 4 more charges. So that's the end of it for doing this. To give you the clean answer, this is a triple bond with, that's a Lewis structure, and positive charges is going to be plus here, and overall charges plus. And each one satisfies the octet rule. Okay? So octet rule is really the bare minimum. And the second one is like this, with satisfying the octet rule here, here, and here. Once again, the 4 more charges develop here, so overall charges is -1. The antimony, which is Sb, has 6 bonds with chlorine, and each chlorine, I'm just showing the one example here as a lone pair electron, and this one is a 0, 0, 0, 0 formal charges. And then the overall, it is a negative 1. That means antimony in the middle is a negative 1 charges. The last one is essentially you solve it from the last week's discussion problem. Very similar to do that. And this one has, this oxygen always has a negative 1 formal charges. This oxygen, 2 lone pair, 2 bonds, no formal charges. No formal charges. And was being told that this is a minus charge overall. That means that this is 0 charges. And that's, oh, okay, I forgot to put the last one, otherwise this one doesn't make sense. So you have this, and so this is 0 formal charges. Once again, trying to remember that this is more than 8 electron, and but it's okay because it's expanded or extended octahedral, because they are not n is 2. Okay, they are something that n is 3 and above. Those elements, they can have an expanded octahedral. Thank you for your attention.